Howdy, howdy. This is Mr. Elmhorst with the help video for the mastery practice. We're going to take a look at the QSE and some of the questions and look at the strategies that we can use to help us get mastery in solving them. So the first one, we got 90 sports cards, and they're broken down into fractional parts. We have 1/5 for football and 1/3 for soccer, and then there were some other cards. So I wanted to borrow the modeling from part total. So you can draw a quick little model on your paper. And the total amount, let's take a look at that. So we have 90 cards total. Okay, and then out of the 90 cards, we have 1/5, the fractional amount. We have 1/5 were football. Got a little glitch there. Okay. 1/5 were football. And 1 out of 5 is kind of a small amount. And then we have 1/3 were soccer. 1/3, 1 out of 3 would be like 33 hundredths, 33 out of 100. That's a little bit bigger amount. And then the question mark. How many other cards are there? Okay, so this is football, soccer, and other. So we're just identifying what is in the problem. We have a couple of fractional parts out of the total. So the fractional part, we're going to multiply 1/5 times the total. So 1/5 times 90 would give us 90 over 5. And then we have 1/3 out of 90. And that would give us 90 over 3. And 90 divided by 5, we'll take the fractional part and turn it back into how many cards we're talking. So 5 goes into 9 one time, 1 times 5. 4 left over from the first digit. 5 goes into 40 8 times. So we have 18 football cards, and 9 divided by 3 is 3, and then 0 divided by 3 is 0. So then 30 cards are soccer. So the question is, how many other cards are there? Well, we're going to add those two amounts and then subtract them from 90 to find how many are other. Okay, looking at question 2. So it looks like we have some rational number operations here. We have 4 of these cheeseburger meals, and they're going to be delivered. So 4 cheeseburgers and delivery. So 4 of these, 4 cheeseburgers, each cost $7.49. So for each, we would multiply $7.49 times 4. And then we have the delivery fee of $5.25. So we're going to find out how much the cheeseburgers cost, and then the delivery fee, and that will put it together for a total cost. We can actually use part total a little bit for this one. So after you multiply, we're going to add the delivery fee to calculate the total cost. Okay, and take a look at number 3. We have 4 and 1/5 hours and 3 hours. So we have 4 and 1/5 hours and 3 hours. So that's going to give us 7 1/5 hours. Now, each one of these hours are being paid per hour. So it's $12.75 times every hour. So we got 7 1/5 hours times 12.75. So the only conversion we really need to focus on here is going to be 1/5. So 1 divided by 5 as a fraction becomes 1 going inside long division for longhand divided by 5 on the outside. So 1 out of 5 is going to be 2 out of 10. 2 times 5 is 10. So this becomes 7.2. So we're going to use 7.2 times 12.75. Looking at question number 4 here, we have a total bill for fixing the car is $368. So the total bill is $368 total, and that's going to come from $80 and the repair charge of $48 per hour. So we have $80 as one part of the total, and then we have 48 times each hour, $48 times each hour. Well, we're going to add these up to get the total of 368. We have 80 plus $48 times H, which is 368. And we can take the H, that dot out of there. So this is going to be our equation. We have $80 plus 48H, and that equals our total amount of 368. $80 and $48 times each hour to 368. So now we are going to focus on our variable term and then starting to solve. So we need the some number of hours as our input. So after some number of hours goes into the input, then 368 is the output. So we are going to work the problem backwards from the output to take us back to the input. So the way we work it backwards by seeing where we started and then doing opposites to get back there. We're going to subtract 80 from both sides of this equation, starting with where the variable term is. Now, 8 minus 0 is 8. 36 minus 8 is going to give us 28. And then instead of multiplying by the input, multiplying the input by 48, we're going to divide by 48 to help us find what was the input of hours to the situation. So now we have H is equal to 288 divided by 48. So there's one way to estimate this here. 4 goes into 28 7 times, but then there's an extra 8. So try multiplying 6 times 48. 6 times 8 is 48. 6 times 4 is 24 plus 4. And I said 48, but then I wrote, there we go. So 6 times 4 is 24 plus 4. And then we have no remainder. So the input to this situation for the variable would be 6 hours. And then we have 6 hours times 48 plus 80 would give us the output of 368. Okay, so we're going to write an equation and then solve for x. So the equation, first looking at the model, we have 3 negative something variables, negative x. So we have 3 negative x. And then we also have 1, 2, 3, 4 negatives, 4 negatives, and then an equal sign. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 positives. Now, in order to find out what this input is for x, we're going to start solving, doing inverses going backwards. So we're going to circle the variable term and put that on hold for right now. And we're going to inverse what is going on with the variable. So the opposite of minus 4 is plus 4. Then we bring the variable term down to the next step. And then we do what we did in step 1, but we do it to the right side also. So that gives us 18. So the input is x. X times negative 3 will give us an output of positive 18. So how do we find that input? We divide by negative 3 to help us inverse and reverse what it was happening. So 3 divided by 3 is 1. X is equal to 18 divided by negative 3 will give you negative 6. Okay, looking at number 6 down below, we're going to write the inequality and then solve for x. Look at the variable terms here. We have 3 somethings, 1, 2, 3x. And then we have 1, 2, 3, 4, 5, 6. 6 negatives is greater than 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 negatives. Okay, so we wrote the inequality. Now we're going to circle the variable term and assign to the left. And this is positive. It's positive, so there's no flip for the inequality sign. And then we start inversing. So the opposite of subtracting 6 is going to be adding 6. And we bring down 3x. And on the number line, these are negative 12 and then positive 6. So on the number line, if we go negative 12 and then we turn around and go positive 6, we're going to stop here at negative 6. We're going to go left, then right, opposite subtract, so we end up with negative 6. So now we go back to the x input of something times 3 is greater than negative 6, so we're going to divide by 3 to help us solve for the something. So x is greater than negative 6 divided by 3, which is going to give you negative 2. What values of x is not in the solution set for the inequality? All right, so let's start with the inequality. Negative 3x plus 6 is less than 9. Okay, so we need an input question mark that will give us an output that is less than -9. All right, so let's just keep that in mind as we start to solve. So we have a -3x. This is negative. So that means we're going to flip the sign during the solving process. Okay, so we're going to subtract 6 from the left side to help us solve. Then we go to the right side and we subtract 6. Bring the variable term down to step 2. And this is -9 and -6. So they're going in the same direction and they have the same sign. So we are going to add those numbers, which is going to give us -15. All right, so we have an input of x times -3. So we're going to divide by -3 and divide by -3 on both sides. 3 divided by 3 is 1, and then a negative divided by negative is going to be positive 1x. So this dividing by the negative is what is flipping our sign. So up here, a negative variable is less than, but a positive variable is going to be the opposite sign, which is greater than. Okay, so 15 divided by 3 is 5, and then a negative divided by negative. So the input is any number that is greater than 5. I had to update the answer choices, so the video is matching up with your answer choices now. So any number that is greater than 5. 15 is greater than 5. 9 is greater than 5. 7 is greater than 5. 6 is greater than 5. What value is not in the solution set to the inequality? 5 is not greater than 5. It's equal to. But there is no equal to sign down below, so we cannot have it not equal to 5. Okay, just solve the equation. Circle the variable term. Separate your left side and the right side. We're going to start on the side with the variable term, but we're going to do opposites away from the variable. We're going to add 8.3 to both sides. Bring the variable term down to the next step. So we got 3 plus 7 is 10, carry the 1, 6, 7, and then that's going to be 15. And the opposite of multiplying by 3. So the input is something times 3 is equal to 15. So we're going to divide both sides by 3 to find x. And this is not needed anymore. It's a whole number. All right, and then the last one here. So all angles in a triangle add up to 180 degrees. So no matter what is in the triangle, whatever is in the angles, if we add them, it's going to equal 180 degrees. So we're going to take all of these things and put them in an equation, add them up. So 45 plus 15 plus 5x plus 10. Okay, so we've got all of these. They don't equal 90. They don't equal 90. So now we have to see which one matches up with what we're looking for. Okay, so looks like we have 15 plus 10, so that's going to be 5x plus 25 plus 45. All of that equals 180. And then we can put these together, they're numbers by themselves. So we have 5x plus those two, 25 plus 45. Okay, make sure you turn in your work and click submit. Go back and make corrections on anything that you might have missed.